Good morning. My name is Chuck Wetherington. I'm the president of BTE Technologies. And on behalf of our host, Beka, we'd like to say thank you for having us here today. Today we're going to be going through an overview of the PrimusRS technology and its capabilities and applications for assessment and physical rehabilitation. I'd like to introduce Jonathan Cooper. Mr. Cooper is a vocational rehab specialist, and he's is part of the clinical team at BTE. Travels the world doing training, installations, working with clinicians on solving problems and applications. So I'm very excited to have Jonathan here. He'll be taking us through the presentation, and we look forward to the interactions with you and your questions. So again, thank you for having us, and Mr. Cooper.
Thank you. So yes, I've been with BTE for about 22 years now. Prior to starting with BTE, I worked at a couple of different hospitals in their industrial rehabilitation program, doing functional capacity evaluations, work hardening, work conditioning, ergonomic assessment, and return to work evaluations. And during those years at the hospital, I did use BTE equipment as a clinician, so I have experience from both ends of the machine. So what we're going to do over the next couple days is go through some applications of the Primus system. We'll be talking about both evaluation and treatment applications with some demonstrations and examples as well. We're going to start with introduction of terminology and calculations. I like to start that way because it gives you a background as to what we're doing with the machine and how we're presenting the data. That gives you insight then into interpreting the results as far as how well your patient is performing and how to use that information in gauging patient results. We'll also be going through a demonstration of a picture of some attachments, some different ways of utilizing the machine. We'll both have some slides as well as we can do some demonstrations on the machine. And then we'll be going into evaluation of muscle performance. This is an evaluation technique that allows you to establish a baseline performance level for a patient to assess whether that person is making improvements or not. There are also additional specialty tests that we'll be going through to look for special performances of patients in certain situations, and we'll talk more about that. One of those is consistency of effort testing and lifting evaluations. And we'll also be going through treatment applications. So key terms and concepts. We're just going to go through a little bit of background of terminology, a little bit of the physics behind the calculations of the numbers that we're looking at before we get into actual demonstration. So we're going to talk about the key terms in terms of defining what strength is, assessment of muscle performance. We're going to talk about measurement units of interest, the biomechanical factors affecting muscle performance, and again, the calculations needed to measure those. So when we talk about muscle strength is the capacity of a muscle to produce force and generate active tension. You have motion or lifting or movement if the force generated by the muscle is greater than the resistance that the muscle is trying to overcome. And we assess muscle performance to establish baseline strength measures, assess physical readiness or athletic readiness to return to sport, to look at muscle weakness or fatigability, to look at functional progress, disease progression, or the effects of surgical procedure. So the measurement units that we use in collecting information about patient performance include looking at the force that the person's able to generate, and that can be measured in newtons or pounds or kilograms depending on what test you're in. We look at torque, measured in Newton meters. Distance is measured in degrees of motion. The system is designed with a central shaft that rotates. So one complete revolution of a tool will be 360 degrees, and that's how we accumulate the motion or the movement of the tool. Time in an activity is measured in seconds. Work output is reported in joules. When we assess power performance in a test, that's displayed in watts. And then for consistency of performance, consistency within a set of trials, we look at coefficient of variation. So the force that we're dealing with, force is a push or a pulling force, and you're applying a force to an object to try to move it. Again, in the software, we can set that to be in newtons or Newton meters. And then just a little physics background kind of gives you some conversions as far as kilograms to newtons and Newton meters there. Torque is a twisting force. It's a rotational force of the shaft. Torque is measured, or torque is calculated by taking the amount of force the person is generating and multiplying it by the lever arm or the movement arm. So for this particular tool, if we set a force, the torque is the rotation of this tool. The lever arm is the distance from the center point of rotation to where the handle is, and then the force is being applied to the handle. So again, distance is measured in degrees of rotation. So if we insert an attachment and rotate it all the way around one time, the screen would display 360. So we use, again, degrees to measure distance. You can think of distance as like a repetition counter. If you're doing a motion and the total motion for each repetition is, say, 200 degrees, and you want the person to do 10 repetitions, you would do 200 times 10, or 2,000, and so that's what the degree goal would be then for 10 repetitions. Or if you want to count how many repetitions a person did during the exercise, at the end of the activity, the screen will display a total of degrees. You just divide that by degrees per rep then, and that'll give you total repetitions. And then time. Time on the machine is measured in seconds. So anytime you're setting a time goal or you're measuring an activity in terms of how long it takes, the machine will display how many seconds the activity was done. There is one particular screen, the CPM screen, where you can actually set a time goal in minutes and seconds, but in all other screens, when we're measuring time, it's displayed in number of seconds. Work output is the quantity of exercise that's produced during a session. Work is calculated by taking the amount of force that the person is working against multiplied by distance. Force times distance gives you your work output. And again, we display that on the screen then in joules of work. So you can think of work as a quantity score. It's how much the person accomplished during the activity. Every repetition a person does, they've done more work, and their work value score will go higher. The power calculation, the power measure of performance is more of a quality score. It's how well the person did the activity. The coefficient of variation calculation is a statistical measure of the amount of fluctuation between a group of scores. So, assessing muscle performance. There's different types of muscle performance. When we talk about different types of measurements, we can look at isotonic measurements, isometric measurements, and isokinetic measurements. And then for the dynamic activities, which is your isotonic and isokinetic, you can also look at the phases of muscle contraction, including eccentric muscle contraction and concentric muscle contraction. In an isotonic resistance, we're looking at a dynamic form of measure where we're controlling the amount of weight or controlling the resistance that the person is working against. The term isotonic means constant tension. So the tension on the muscle or the resistance that the muscle is working against is the same through the range of motion. What varies is the velocity of the muscle contraction. So velocity is not controlled during an isotonic exercise. Most everyday tasks are performed isotonically. Anytime you lift an object to place it on a shelf, that's an isotonic activity. The weight or the force of that object remains constant, but you can move it fast or slow to place it where it needs to be. In an isometric exercise, there is no motion. So you're applying force to an object, but that object does not move. The isometric mode is used as a way of assessing somebody's maximum strength output. The third mode of resistance that you have is isokinetic. Isokinetic resistance is also dynamic, and it occurs when the velocity of the muscle contraction is controlled, but the resistance is left variable. So in an isokinetic activity, you're controlling the speed at which the limb can move through its range of motion, but the amount of force that the person exerts through the range of motion can vary depending on where they are within that range of motion. Isokinetics is not as common as it once was because it's not very functional. There's really nothing that a person does in the real world that is done in an isokinetic way. It's usually isometric or isotonic. So there's also a mobility and stability that you have to consider when you're looking at assessment of performance. Stability results when you have a balance of competing forces. Movement occurs when the competing forces are unbalanced. So forces generated by muscles is the primary means of controlling the balance between posture and movement, via stabilization of bones and movement of bones. So what we use the Primus for is to measure functional performance for rehabilitation and testing. You can do both open and closed chain activities. You can do specificity of training where you're doing work or sport-specific movements or work-related activities. You can work at low speeds for stability and motor recruitment. And you can work at high speeds to develop skills and enhance motor performance. The next section we're going to go through is what we call evaluation of performance. So this is a testing section that allows you to assess what a person is able to do at any given point in time in their rehabilitation program. There are different reasons for testing an individual and different types of tests you can choose depending on what you're trying to find out about that individual's performance. So to choose the proper test, you need to know what you're trying to find out about that person's performance. And there's different types of evaluation objectives. One objective is to perform baseline testing to document where they are right now so that you have something to compare it to later on to see if they're making improvements. You can also do testing to compare the injured extremity to the non-injured extremity. Evaluations allow you to assess how much progress has been made in rehabilitation. So when you're starting to test somebody, a good place to start is the standard protocol for measuring maximum muscle performance. That's an evaluation procedure that's been used on DT equipment for 30 years. and it allows you to look at different levels of muscle performance. There is an isometric strength component, which allows you to measure their maximum strength output capability. There's a dynamic power output test. Remember, power is a measure of efficiency. So this test will tell you how efficient they can use the strength that they have. And then the third component is an endurance test. For endurance testing, we look at how much work they're able to generate before they reach their fatigue point. So with these three different tests, you're assessing how much strength they have, what's their efficiency at using their strength, and how long can they maintain that strength level until they reach their fatigue point. In the isometric strength test component, we're looking at how much force they can apply against the handle that doesn't move. When you're establishing somebody's maximum strength, the most common mode to use for that is isometric. As soon as you do motion, you're reducing the maximum force output that person would be able to exert. Other test termination criteria, again, compensatory movements or substitution patterns, so that would be a biomechanical limitation. If there's a significant loss of range of motion or slowing of their pace, if the client states they cannot continue giving you a psychophysical response, that would be an indication to stop. For treatment is a series of exercises that you're going to do with an individual to try to improve performance. There are many different types of applications that treatment with the Primus system will fit into. It can be used with back conditions, sports-related injuries, upper and lower extremity injuries, clients with arthritis, CVA or stroke patients, head injuries, amputees, cardiopulmonary reconditioning, just about any kind of a medical condition. If there's a deficit that you're trying to overcome, there's an activity with the Primus you could do to help that person overcome that deficit. So in establishing a treatment program, there's different questions you have to address in terms of how do you choose the appropriate exercise for the individuals, how do you choose which attachment on the Primus is the best one to use for that activity, what sequence should the exercises be placed in, how do you choose the level of resistance to exercise the person at, how do you set goals for that individual, and how do you look at progress in treatment. So we'll kind of look at each of these components of treatment in a little bit more detail. So again, to review the three basic elements of any work activity, anything you do in life can be broken down into three components. The force or the strength required to move the activity, how far that person needs to move that object, and then the time requirement. Okay. All right. So looking at those three values, again, we can then calculate the work output, or how much is done during the activity. We take the force and multiply it by the distance, that gives you work output. I know that the picture of the home screen that I had up on the PowerPoint slide was very small. So here's a larger version of that, just to kind of reintroduce you to this and what's available on the home screen. So the way we would control the resistance is on the right side of the screen. Right now the system is set in the isotonic mode, concentric. So we're going to have muscle loading in both directions, loading opposing muscle groups. In that way we can control the counterclockwise rotation resistance and the clockwise rotation resistance. So depending on which muscle group you're working on, if you want to do flexion and extension, you can set different resistances in each direction for elbow flexion extension. Usually a person is stronger in the flexion direction and they're not as strong in extension. Your biceps are stronger than the triceps. So with that, you can set the resistance differently. So if I'm doing this with my right arm, flexion would be in the clockwise direction. I can set the flexion direction higher than the extension direction. So right now I have it set to 9 Newton meters in flexion and 4 Newton meters into extension. So I have a different load in each direction of the tool motion. That way you can appropriately load each muscle group within the same exercise. If you want the resistance to be the same in both directions, there is an option on the bottom to synchronize the resistances so that they're the same. To start an exercise, once you have the resistance set, you just hit the start button and it'll start collecting information about what that person's doing. So if I hit start now, you can see it's showing me movement through range of motion in that green circle. And then it shows the 100% power level, 100% power for that first 5-second cycle. During the second 5-second cycle, I actually did a little bit more work, so it's showing about 115% of what I did during the initial 5-second cycles. The objective for the patient then, for feedback, is to try to maintain their activity so that their power level remains the same. So the power level remains the same. In addition, again, it's accumulating how much work the person did during the exercise, what their distance was. With the range of motion chart, to provide additional feedback to encourage proper exercise movement, you can set markers on there to provide visual feedback for the person. So if I want the person to go from here to here and make sure they go through that full repetition, I can set that as my start position by clicking on Mark Range of Motion, have the person go through 1 repetition, and then hit Mark Range of Motion again. So I've marked a range of 88 degrees, and now I've got a feedback screen, and I can just watch to make sure that I go through that full range of motion with each repetition. You can also activate a tone, and I'm not sure if you'll be able to hear this or not, but to indicate when I've hit that end point, so I know when I can go the other direction. When you're finished with the exercise, you can just press stop. There is no option to save this information because it's just on the home screen. You're not working with a specific patient. Like I mentioned before, the home screen is really just kind of an area to try things out with your patient to make sure it works the way you expect it to. You can print the results if you want to, but there's not an option to save it in the database. The second mode of operation that you have is the concentric-eccentric mode. So if I clear this exercise and change it to connect, something with all those laptops, it's not controlling it correctly. But what it does when it's in the concentric-eccentric mode, it changes the labels to have a concentric and an eccentric direction of resistance, and they would automatically be synchronized together. So you would always have muscle loading in one direction, but that loading would be with the muscle shortening for concentric, and then with the muscle lengthening for eccentric. One other option you have on the home screen is to select what tool you're using and insert the lever length for that attachment. Right now, there is no lever length set, there's no tool selected, so the default measurement for resistance, or the default settings for resistance, is Newton meters. If we select a tool that has a specific lever arm, for example, if we select if we select like the steering wheel attachment, it will automatically fill in the proper lever length for that tool. And you see it also now has changed the units of measure over here. Instead of Newton meters, it's converted to newtons. If you choose an attachment like the 701 that has an adjustment to it, where you can change the length to match the limb size of the person you're working with, you'll have to manually type in that information. So that's the home screen setup. If you want to go into the evaluation mode or the treatment mode where you're saving results for that individual, you do have to create a record in the system with that person's name on it to be able to save that information. To do that, we'll just go to the patient records section. And I'm going to choose the option to add a new patient. And I'll just put my name in as our new patient. So once you've created and saved the record, their name appears up here on this title bar. So now I can go into my evaluation setup or my treatment setup, create a program for that individual, collect the data, save the data, and then also go into reports to look at progress of that individual for those items. So the first thing we'll look at is the evaluation setup options. You can custom build tests using whatever parameters you want. There is the option to do isometric testing, isotonic testing, and isokinetic testing. And there's a power output test where we look at the person's peak power generation based on their current strength level. And then finally there is an endurance test, which is the test we use to measure how long a person can maintain that strength level until they start to fatigue. So each one of these four tests tells you something different about that person's ability to use that body area, that muscle group, or that joint. If you wanted to test additional body areas, for example, say you want to test shoulder external rotation, which is what we selected, and you also want to test elbow flexion, you can assign that template to the client as well. So now we have the elbow flexion template, and you can see it contains the same four sequence of tests. So Waldo has volunteered to be my demonstration subject, and we're going to go through the sequence of tests for the shoulder external rotation. That way we can look at the screens in real time to see the data collection, and then also talk about the results and interpreting those results.
The software behaves the same way, whether it is knees. The software behaves the same way, whether it's a shoulder, a knee, hip, elbow. It's the same way.
So for the setting for shoulder external rotation or internal rotation, you have different ways of setting it up. It's just a matter of what you prefer to do it for your patient or what's appropriate for that patient. There's different ways of setting it up. We'll do your left side. So what I'm going to do now is just configure the setup so it matches Waldo's body size, which means the length of his arm, proper height. One thing I've noticed the way this is set up now looking at him is his left shoulder is a little bit elevated compared to his right shoulder. So that means I just need to drop the height a little bit to put it in a more even plane. So the first test in the sequence is the isometric test. This is what we're going to do to establish what his maximum strength level is. So to perform that test, you just got to highlight it and then go to the evaluation screen. And it shows you a graph for the left side and then the right side. We'll do 3 trials on the left side to determine maximum strength. Then we'll switch, have him turn around, and we'll do 3 trials with the right side. At the end, we'll be able to do a comparison to see if there's a strength difference between right and left. Now, the test position, since this is an isometric test, there's no motion, the test position is usually about midway through their range of motion. Most people are strongest at the midpoint of their range. You're weaker at the ends, and you're stronger in the middle. So we're trying to measure his maximum strength. So I'm going to put him in a position where I feel he can generate his best force output. So this is now locked, meaning it's in the isometric mode and he can't move it. But we'll be able to measure how much force he's generating. And then I'll press start. And push out as hard as you can. And relax. So each trial lasts 3 seconds. Give them a short rest period. And then tell them you're going to repeat and do the same thing again. Ready? Again, push as hard as you can. And relax. What we're capturing is the peak force exerted during each repetition. One more time. Ready? And go. Okay? So in this case, we have 3 values, 3 peak values. We average that, and then give you that coefficient of variation number. Again, that's the measure of the consistency of those 3 trials. This number by itself, this 92 newtons, is simply documenting what his left side external rotation strength is right now. What we need to do is get the right side tested so we have something to compare it to be able to see which side is weaker. So I'm going to change to the right side test screen. I'm just going to click on right side. And I'm going to unlock the resistance so the tool can be moved. That releases it, so now I can move it to the other side to do his right arm. And then once you lock it in place, now the tool can't move again, and it'll be able to measure his maximum force output. And go ahead and preload it. And go ahead, push as hard as you can. Push, 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 push. And relax. Okay, second trial, ready? And go ahead and push, 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 push. And relax. One more time, ready? And go ahead and push, 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 and relax. So in this case, on his right side, you see that it's 45.5 newtons. Coefficient of variation was 3.7, so there's still good consistency with those scores. And in the difference comparison, it says that the strength in his right side external rotation is 51% weaker than his left side external rotation strength. That's a pretty big strength deficit. That's a pretty big difference between, say, an injured and a non-injured side. If this was my actual patient, if this was really somebody with a shoulder issue, after completing this test and seeing this result, I probably would not do the other tests because I know I need to do some strengthening on him. I know there's a weakness right there. So I'm going to save these results. At least it wasn't clear. So I'll save those results. And then I would go into the treatment plan then and set up a training program to do some strengthening for shoulder external rotation. But to continue on with the evaluation, just to show you what the rest of the tests look like, we're going to go ahead and continue to next test, which will take us to the torque versus speed test. That was the next one on the list. Now again, just to do a quick review here, we're going to be testing his left side external rotation first. And then here are the 3 sets showing the 3 different resistance levels that were calculated based on the results of his isometric strength. The first one is 25% of what his maximum was. The second one is 37.5% of his maximum. And the third one is 1/4%. The instructions that you give the patient for this test is to try to move the tool as fast as they can through their best range of motion for each trial. So they're going to be in internal rotation for starters. When you tell them to begin, they're going to go as fast as they can to external rotation, and then they can bring it back to the start position. I'm going to give him practice trials at the beginning of each set, just so that he can feel what the resistance is like. And then also to make sure that he understands what the test will be like.
Explain the start position. That you measure strength in here from the start position.
Yeah, we're testing through his range of motion, so the start position is going to be on internal rotation. And we're going to measure his ability to move through his best range of motion from full internal rotation. Okay, so that's going to be his start position. Move it as far as you can. And just as I'll clear this one, but in his practice trial, it shows you his power through range of motion and what his actual range of motion was during that repetition. So I'm going to clear that. And now I'll ask him to do it again, but this time move as fast as he can safely through his best range of motion. Ready?
Ready?
Go. Second one, ready? Go. And third one, ready? Go. Just do a quick review of the 3 trials, make sure they appear consistent. If one of them is significantly different from the other 2, you can highlight it using the previous trial button and then erasing it using the clear button to do a replacement trial. These are very consistent looking though, so I'm going to go ahead and keep those. I'm not going to have them do one of those over again. So that was the light resistance. What we're going to do now is change to set number 2, which will be the medium level resistance. So this is practice whenever you're ready. Okay? Wait till you do the next one. Go. Go. Okay. Again, we'll just do a quick review for consistency. Again, they look very good, so then we'll switch to the high level of resistance. Once we finish the test for both sides, we'll bring up all the results together on one screen and talk about what they say. All right, so this is going to be the practice one for the heavy resistance. Are you ready?
Yep.
Go ahead and practice. Okay. And we'll clear that. And as fast as you can, ready, go. Go. And go.
That last one was too much. I'm going to work to eliminate the last one.
All right. He cheated a little bit on this last trial. You see how much different it is? He kind of went like this. Instead of just using his shoulder, he went like that. So I'm going to erase that one and make him do that one over again. Okay, ready? Go. much more consistent, didn't really cheat that much on that.
You can do this sitting or standing. I think she got it. I said it loud enough.
All right. To change to do his right side, we're going to go to side number 2. The bottom of the graph is set up so that you could do external and then internal rotation. But since we didn't do the isometric internal rotation, I have no test forces. So we're just going to skip that one. And I'm just going to go to side number 2. And then it will set the resistances now based on his strength for his right side external rotation. 25% plus 50% plus 50%. Right. So this first one is going to be practice again at the light resistance moment. Go ahead and practice. Okay? All right.
Was that 160?
140. All right, so ready, go.
That was 160?
Go. Go.
That means your motion was lower speed for analysis.
Okay. All right, so again, good consistency there. We'll go ahead and move on to the middle one, the medium resistance. And this first one will be practice. So whenever you're ready, go ahead. All right? Okay, so as fast as you can, ready, go. Ready, go. And go. Okay. And this first one will be practice at the heavy resistance. Whenever you're ready. And this one will count. Ready, go. 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 Okay. So that's the last of the 3 trials then for the right side. Now to bring up the results so we can see all 6 graphs on one page, I'm going to print the report and it'll display all of them in the print report.
I give you lower speeds on the right, good range of motion on the first 2, shorter range of motion on the third on the right side.
So looking at the chart in the first section of the report, this is the trials 1, 2, and 3. So this was the light, medium, and heavy resistance for the left side, and then the light, medium, and heavy resistance for the right side. This is showing the range of motion, the velocity, the coefficient of variation of the velocities. This is the power output and the coefficient of variation of the powers. Now if we scroll up to look at the graphs, oops, not a touchscreen. So here's his left side, light resistance, medium resistance, heavy resistance. And here's the right side. Yeah, right side. Light, medium, and heavy. If we look at the range of motion, it was 175 degrees at the light resistance. At the medium resistance, his range of motion dropped to 142. And at the heavy resistance, it dropped to, I think that's 120, 126. So there was a decline in range of motion. Normally for somebody who has a healthy performing muscle, you see about a 10 to 15% decline in range of motion from the light to the heavy resistance. His range of motion declined about 20%, if I do quick math in my head. About a 20% decline, which is a little bit more than expected, but it's not necessarily out of line if he's not injured, and that could be just normal for him. If we look at his right side, it was 156 and then at the medium it was 155, and at the heavy it dropped to 108. So that's almost a 30% loss of range of motion on his right side. That is a little bit more significant. So his functional movement at heavier resistances is only within a small range. He can't get to his full range under those loads. So that's the torque versus speed test. It allows us to look at power output, velocity of muscle contraction, and range of motion under load. So it gives you a lot of information about that person's ability to use that muscle group in a dynamic, functional way. Our left side and right side again, and then it automatically calculated 50% of his maximum for this power test. The process for the patient in this test is to try to do as many repetitions as they can for 10 seconds. So the 50% and the 10-second time frames for this protocol come from published research that looked at optimum power performance levels in individuals. I'm going to start the test and I'm going to let him do 2 practice trials, again, just so that he can feel what it's like. Go ahead and do 2 practice trials. Okay. And we'll just let him rest while the timer runs out. When it reaches 10, it'll stop. And then we will clear that. Okay. So you're going to do this as fast as you can for 10 seconds. Are you ready? Go. Push up. Push up. 7, 10. Okay.
I should have gone 50 and 25, not 90.
So the result here says he generated 31 watts of power. Is that a good score? Is that a bad score? It's just his score at this point in time. I don't have anything to compare it to. There's really no norms for how much a person should be able to generate for power output for shoulder external rotation. We're primarily collecting this information so that we can compare injured to non-injured and use it as a way to measure improvement over the course of his rehabilitation program. So I'm going to change over to the right side now. And the resistance will automatically adjust to 50% of what his strength was for his right side. And we'll have you do 2 practice trials again, just so you can get a feel for that resistance. Okay, practice. Okay. Short rest. And now do that as fast as you can for 10 seconds. When I say go.
Yeah.
All right. And go. And that's 10. So 31 watts on his left side, 12.9 watts on his right side. That's the difference of 58%. So let's save that result. And then the last test in that series of 4 is the endurance test. And we can access that just by clicking on Next Test. And it shows left side and then right side external rotation. Now the objective of the endurance test is to measure how long a person can maintain his strength level until he fatigues. Another thing you want to do to make sure you have a fair comparison of right versus left is make sure that the range of motion is the same for both extremities and that the speed at which the person's moving the tool for each repetition is the same. All right, so are you ready? And go ahead. Up, down. So again, if we're able to set the pace, there'd be a visual up, down, to help him control his pace. What we're looking at is his power output for every 5-second cycle. Go ahead and start. First 5 seconds is always 100%. And then So 503 joules on his left side, 226 on his right, 55% different. So his power output also is around 50% less for his right side as compared to his left side. So these 4 different tests give you 4 different ways of looking at how that person uses their muscle strength.